Alright, so we've made it to chapter 10, and so we're looking at correlation and regression. So this is just a table of information, and we're going to construct a scatter plot. So I'm going to open our data into StatCrunch. And if I wanted to make a scatter plot, I could go to scatter plot. But where I'm going to recommend that we go whenever we're doing chapter 10 material is let's just go to regression and simple linear. We're going to say the x variables are our x terms and our y variables are our y, and we're just going to compute. Now this gives us more than a scatter plot, but if I slide over, I also get a scatter plot, right? And I see it has a nice curve to it. Might imply that it's not really a linear relationship, but we'll find out. So it looks like this one. I can calculate a correlation value for anything, any two sets of variables. So let's go back, and this R value, our correlation coefficient, is right there. So 3 decimal places would be 0.817. 0.817 doesn't sound terrible. Determine whether there is sufficient evidence to support the claim of linear correlation between the two variables. And so if we look at this table of critical values, there should also be a table in your book. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 data points. Alpha is 0.05. So if n's 11, anything bigger than 0.602 means that it would have a good relationship. So that's how we read this table. So we have 11 points. Anything larger than 0.602. If this would have been a negative 0.817, we would look at the absolute value of that and say that the absolute value of negative 0.817 is also larger than the 0.602. So there is sufficient evidence to claim that a linear correlation between the two variables. There is sufficient to say that it's linear, even though, again, the look of it does look maybe like it's a quadratic, something of that shape. The scatter plot reveals a distinct pattern that is not a straight line pattern, so that would be something that I would notice. Again, this information over here, this gives us information that we will use in section 2 and section 3. Let's look at another one. I think I was going to 8. So here they put some hypothesis testing, and they're talking about the correlation coefficient. Is it 0? 0 means that there's not a relationship, or is it not equal to 0? Because again, if it's positive, close to positive 1 or close to negative 1, along with that table, we can show that there is a linear relationship. So our first one is we're just trying to determine that there is a linear relationship. So that means null hypothesis is that there is no relationship. Alternative is that there is. So I could take the data, put it in StatCrunch, and again, I'm going to suggest going to regression and simple linear, brain volume, and IQ score. The bigger your brain, the smarter you are. It already has our information for our hypothesis test in here. So when we're looking at this, we see all kinds of things. Some information that we haven't looked at before. We have these p-values, but those are for intercepts and slopes. But we also have a nice scatter plot, which kind of looks haphazard, right? If we look at our R value looks pretty weak. Negative 0.05, it's really close to 0. So let's see if we can answer these questions. The scatter plot, we just saw it. Again, kind of weak looking. Maybe this one. Oh, already checked, good. The linear correlation coefficient R is that negative 0.054. Alright. Then the test statistic T, so when we're looking at this one, alright, the test statistic is found, if we look at our slope, we're going to see how well our slope matches up. So our test statistic is the negative 0.227, and then its p-value is 0.823. Again, so that's rounded to 3 decimal places. And that p-value is way greater than that alpha is greater than, there is not sufficient evidence. So we are not rejecting the null, we are accepting the null, saying, hey, there is not a good relationship between these two variables. Again, so we can find all that information under stat and regression, simple linear.